Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about operations on functions. All right, so we're going to take two functions, f of x and g of x. And by the way, we can read f of x as f of x. And f of x is equal to x plus 2, g of x is equal to 5x. And again, we can consider these functions f of x as the value that you get when you substitute x into the function. So you produce a value that's basically y. So f of x can also mean y. I'm going to substitute some value in for x, and then I'm going to get a result out, and that result is going to be f of x, or also we can consider it as y. So for example, if I say x is equal to 2, f of 2 is equal to 2 plus 2. So f of x in this case is equal to 4, or y would be equal to 4 if you were to graph this on a coordinate plane. All right, so we're going to take these functions and we're going to add, subtract, multiply, and divide. I'm going to say h of x is equal to f of x plus g of x. F of x is x plus 2, g of x is 5x. I'm going to add the two together, 6x plus 2, 5x plus x, 6x plus 2. And I put the parentheses around just to identify these two functions as quantities, and so that we take the appropriate steps, especially when we're subtracting or multiplying. All right, subtraction, f of x minus g of x. So here I need the parentheses, x plus 2 minus 5x. X minus 5x leaves us with negative 4x plus 2. So f of x minus g of x is h of x. Now I can change the order, and the order matters when we're subtracting one value from the next. So 5x minus x plus 2, and again, parentheses required here for the quantity of f of x, becomes 5x minus x, distributing the negative sign, minus 2, which leaves us with 4x minus 2, which is not the same as f of x minus g of x. So 4x minus 2 different than negative 4x plus 2. All right. Third operation, multiplication. H of x is equal to f of x times g of x. So I'm going to multiply f of x, x plus 2 times 5x. It becomes, we're going to distribute the 5x across x and across 2. It becomes 5x squared plus 10x. And then lastly, division, f of x divided by g of x, x plus 2 divided by 5x. We'll represent it this way. And then let's talk about simplifying fractions. So if I have in the numerator two terms which I'm adding together, then in order for me to reduce them, if there is a factor in the denominator that's part of the numerator, that factor has to be part of both terms in the numerator. So in this case, x is part of this term here on the left, but it's not part of the term 2. So I cannot reduce this fraction. This would not become x over x, or 1 plus 2. So in order to reduce when adding or subtracting in the numerator with one term in the denominator, there must be a common factor in every term. And in this case, there's not. So let me give you an example where there is a common factor in each of the terms. X plus 2x, there's a common factor of x in each of the terms. Of course, we could combine x and 2x together to be 3x. So this becomes 1 plus 2, or 5. This is the math equivalent of 3 over 5. All right, so I'm going to ask you to take f of x, x squared plus x, g of x, x plus 1, and then I'm going to ask you to add the two functions together. I'm going to pause here while you evaluate this classwork. All right, so for f of x plus g of x, you should get x squared plus x plus 1, which when you combine like terms and simplify, x squared plus 2x plus 1. F minus g of x, x squared plus x minus x plus 1 becomes x squared minus 1, which is also the product of the difference of two values, x plus 1 times x minus 1, so the difference of two squares here. F times g of x, x squared plus x times x plus 1, x cubed plus 2, x squared plus x. And then lastly, f of x divided by g of x leaves us with x squared plus x over x plus 1. We can factor out x to leave x plus 1 over x plus 1. These reduce to 1, so your answer is x. However, when we're evaluating the domain, we need to make sure that we don't reduce the fraction. So x, in this case, we also need to specify that x cannot be equal to -1, because -1 for x would result in a denominator that's equal to 0, and this fraction would be undefined. All right, so let's move on. We're going to talk about composition of functions. Composition of functions is the inclusion of one function into the other. I can write composition of functions, so I say h of x is equal to g of f of x. So I'm taking f of x, I'm evaluating f of x, and then I'm going to substitute that in for x for g of x, and then I'm going to evaluate that result. So let's do this both numerically and algebraically. All right, numerically first, we'll say x is equal to 5. I'm going to substitute into f of x first, so we're going to work from the inside out. I'm going to substitute 5 in for f of x. So 2 f of x here, 2x plus 2. 5 times 2 is 10, plus 2 is 12. And that's the value that now becomes x for g of x. So I'm going to take that value of 12, and now I'm going to substitute it in for x for g of x. And we're going to evaluate g of x where x is equal to 12. And we know that g of x is x squared. 12 squared is 144. So the final answer is h of x is going to be where h of x is equal to g of f of x is going to be equal to 144. Okay, moving on. We're going to talk about algebraic solution of composition of functions. So f of x is 2x plus 2. G of x is x squared. I'm going to take g of f of x. So I'm going to take f of x first and substitute that in for x and then evaluate. So 2x plus 2 becomes x. 2x plus 2 in parentheses, the quantity squared, is 4x squared plus 8x plus 4. Now I want you to evaluate as classwork f of g of x. I'm going to pause here for a moment while you get the answer. All right, so f of g of x. So now I'm going to substitute x squared in for x in f of x. So it becomes 2 times x squared plus 2, or 2x squared plus 2. All right, so this is classwork. I want you to find the answers here. I'll come back in a moment. All right, so f of g of 2. So we're evaluating numerically and then algebraically, numerically, algebraically. 2 plus 1 is equal to 3. 3 squared plus 3 ends up being equal to 12. F of g of x, x plus 1 squared plus x plus 1, becomes x squared plus 2x plus 1 plus x plus 1. Simplify to x squared plus 3x plus 2. Find g of f of 2. F of x is x squared plus x, so 2 squared plus 2 is 6. Now I substitute that in for g of x, where x is equal to 6. 6 plus 1 is equal to 7. G of f of x, or g of f of x. So f of x here is x squared plus x. I'm going to substitute that in for g of x, and I end up with x squared plus x plus 1. All right, so now we're going to move on. We're going to compose, or actually we're going to create or evaluate operations of functions graphically. So what I want you to do is I want you to add these blocks together. And the thing to think about is that for any given x, we are adding f of x and g of x. And f of x and g of x are the values for y in the function generally. And so if we say that this is g of x and the blue box is f of x, we want to add the values of y for any given value of x. All right, so in this case, the y value, right, is going to be equal to 6. And in this case, the y value is going to be equal to 3. All right, so as we move along the x-axis, so if we say this is the x-axis, for any given value of x, we're going to add the two y components together. And let's see what you come up with. Right, you should come up with a result that looks like this. So if we go back and evaluate, at this point, I have one value for y. It's for the blue rectangle, and this is going to be 6. So I'm going to add that 6 here. This is 6. And then I'm going to move along the x-axis and add the values together. Right, 6, 6, 6, 6 here. And then at this point, I have 3 plus 6, which gives me a value of 9. All right, so then we're going to graph that. And you should end up with a form that looks something like this. So we're adding the blocks together. What we're doing is we're really adding the y values for any given value of x. All right, so I want you to do the same thing here for this particular function. All right, and let's see what you come up with. All right, so it should look something like this. All right, so the box is not centered between the two. We're just adding the blocks where they are for any given value of x. All right, so now I want you to evaluate these two functions. I have the red function f of x and the blue function g of x. We're going to add the y values together for any given value of x. So what I want you to do is create a table of values. And that table of values is going to look something like this. So let me come back to this and write this in for you. Okay, so we have this function. I'm going to create my table of values. All right, so my table of values is going to look something like this. Let me draw this for you. Okay. All right, so we have some x value, and we're going to start with -5, and we're going to go to +5 in this case. And then we're going to evaluate what the value is for red, what the value is for blue, and then add red plus blue, which is going to be red is f of x and blue is g of x. So let's go back. Red is f of x. So red is f of x. And blue is g of x. And we're going to add the two together. You're going to come up with a table of values. And then for a given value of x, you're going to plot f of x plus g of x, which is really just the value for y. Okay? All right, so I want you to take care of that business, and we're going to come back in a moment. Let's evaluate your answer. All right, so you should end up with points that look like this. For -5, you're going to come up with approximately 7 or 8. With 3, you're going to come up with 8. And so the graph should look something like this with the dots. You're going to connect the dots, and it should look something like this. Okay? Now, these are the values that I generated for my table. I didn't fill them into the table specifically. All right, so now I want you to evaluate f of x minus g of x. So let me erase this and write f of x minus g of x. And I'm going to pause here while you figure that out. So same thing, draw the table, take a look at the table, subtract g of x from f of x, and you should end up with something that looks like this. All right, that's it for this edition of Ought in Math. Thanks for joining us. Come back and join us next time when we talk about symmetry over the x-axis, y-axis, the origin, and over the line y is equal to x in the next edition.